All right, take a look at question 5. I had you stop on question 5 for a pretty good reason. I'm sure some of you might have been able to figure it out. But what's different about 5 or 6? There's a plus 2 at the end of one of them. There's a minus 2 at the end of the other one, right? That's a little different. So I had you draw these. I hope you did. Y equals the square root of x. This was a question on the last test we took. If the plus 2 were outside the square root, isn't that what it did? Moved it up 2 units. Now this is something you would have graphed last year. Y equals the square root of x. It's just a parabola. What if I put a plus or a minus 3 at the end of that thing? What does it do? So draw that real quick. So you've had this kind of lesson at least twice already between secondary 2 and secondary 3. It's just these transformations. So if you've written these down already, great. If not, write them down. If you have plus or minus some kind of a number outside of the sine or cosine, all that is a vertical shift. It moves the graph up or it moves the graph down. Everything else is exactly the same. You graph it the same way. You still have to find the amplitude. You still have to find the period. Okay? But rather than starting in the middle, it either shifts up or it shifts down. So let's take a look at this example. We'll do one example here on the board that's not on your worksheet. Then we'll do a few as a class on your worksheet. So it starts the same way as the others that we've done today. You find the amplitude first. Well, I guess you don't have to find it first, but it's probably the easiest thing to find. Amplitude on this problem. What are you thinking? Probably 3. You're right, it's 3. No big surprise there. It's just the number in front of the trig function. Here we have a 3. And you find the period the same way. It's the same formula, which is, well, for this one it turns out to be pi, but what's the formula? 2 pi over b. But in this case, it's 2 pi over 2. 2's cancel, so we have a period of pi. Okay, so we're going to graph this. Before I do though, there's one word I forgot to show you guys last time. So you don't need to write this down. But if we were graphing something like y equals 2 cosine of, I don't know, 4 theta, amplitude is 2, and the period is pi halves. So then you end another one at pi, and then here you have pi 4s. I know I'm going real quick here, but so it starts up here, comes down. Isn't that how we do this? So the graph would look something like that, right? If you cut this graph right here, isn't that about the midway point? Yep. So that's called the midline. No big surprise. Midline. Okay, both the sine and the cosine function have them. It's just halfway between its amplitude. The amplitude here goes up to 2, down to -2, so you cut it in half, that's the midline. You guys follow? Normally, the midline lies right here on the x-axis. Normally. Okay. If there's a vertical shift, like this +3, what do you think happens to the midline? It's going to go up 3 units. So when you draw your graph, whoa, I'm going to make a suggestion here.
I would actually draw in the midline where it's supposed to be. So if you go up 3 units, the midline's going to be right here. How do we know it's supposed to go up 3 units? Because it says a plus 3 right here. Okay. Normally, where is the midline? Normally it's along the x-axis, but if there's a vertical shift going up or down, we got to move the midline. So, you understand what I've done here so far? Okay. This is the midline. And everything else is exactly the same. You just graph things on the midline now instead of the x-axis. So, the period is pi, so I'm going to go out pi units and mark it on the midline here. Because isn't it still pi units from here on the x-axis? Same distance, isn't it? So just mark it on the midline. And then I want you to graph 2 cycles still, so the second cycle would end at 2 pi. Now if you break up the first cycle, what's halfway there? Okay. And then you just got to mark those and those. Alright. I know fractions sometimes you think they're impossible and you're never going to get them, but for these sorts of things, it's just recognizing a pattern. This is 1 pi over 2, yes? Yes or no? 1 pi over 2. So then this one over here has to be 2 pi over 2, which is just the same thing as pi. So then this one in the middle here, if this is 1 pi over 2, and this is 2 pi over 2, this one has to be 3 pi over 2. Which would make this one here 4 pi over 2, which is just 2 pi. Now I need you guys to think for like 2 seconds before you blurt out an answer. Okay. Normally if I were to say the amplitude is 3, that means you go up to 3 down to negative 3. Right? But this graph has moved up 3 units. So the amplitude is still 3. It's going to go up to 6 and down to 0. And then back up to 6 and down to 0. So I'm going to put 3 more marks here above that new middle point. So now we're up 6 units and we're going to go down 3 units back down to 0. So, the sine function. Where does it start? Usually it starts at the origin. Isn't that where the midline is? So the sine function starts on the midline. So it's going to start right here as if this were the new origin. Sine function starts at the midline. And does it go up or down? Always up. If it's a minus 3 in front, then it would go down. But since it's a plus 3, it goes up to its highest point, which is 6. Back down through middle. And then down to its lowest point, which is 0, and then it stops on the midline for its first cycle, right where it started. So other than moving up 3 units, is anything different? No, not really, just moved up 3 units. And then the cycle repeats, goes up to 6, back down through 0, down to 0 on the x-axis, then back to the midline. So, just make sure you're... Oh, that was terrible. Oh, ugly. Trying that again. Not much better, but I'm going to take that one. So let's try number 5 then. Here's number 5 on your worksheet. Okay. Amplitude. 4. Period is 2 pi divided by 4, which is pi halves. Very good. Now make your graph. instead of marking up the x-axis, we have to consider what's happened here. It's plus 2. That means the midline has shifted up 2 units. So I'm going to go up 2 units and draw the midline. Yep. Just so I can remember which one's the midline and which one's actually the x-axis. Okay, again, same question here. Think for just a second before you blurt out an answer. If the amplitude is 4, but we're already up 2 units, we're going to go as high as 6 and as low as -2. We're going up to +6 down to -2. Okay. And now I'm going to mark up the midline with the period. So the period is pi half. Let's write about here. The next cycle would end at pi halves plus another pi halves, which is pi. And then you break these up into smaller segments. Halfway between pi halves and 0 is pi fourths. And then halfway between pi halves and pi is 3 pi fourths. And then you break up these into each cycle or section of the graph has to have 4 sections. Cycle 1 ends at pi halves, cycle 2 ends at pi. Ooh, another sine function. Lucky us. Sine function starts where? Right on the midline. Right on the midline. And then at our very first tick mark, since it's +4 in front, we should be up at the highest point. So it's 4 units up. And then back to the midline. And then 4 units down. And then back to the midline. And then it repeats. 4 units up. Back down to the midline. 4 units down. Oh! And I'm struggling on this. It's because my hands are shaky. I need to go outside and have a hamburger.
That could be a sign of addiction.
I was making a joke. I'm glad you got it, though. Apparently nobody else did. Yeah, anyway. What do you think? Should we try 6 together, or do you think you got it? What do you think?
We should try 6.
Should we do 6? Let's do 6. Y equals, tell me what it is. Y equals 2 cosine 2 theta minus 2. Okay, thank you. One's really howling. All right, amplitude is 2. Period is 2 pi over 2, which is pi. All right, here we go. So we draw the graph, but we're not going to label the x-axis. We need to label the midline. Midline, where's the midline?
-2.
Down 2, okay. So there's the midline. We can mark up that midline now with the period. The period's pi. So there's the end of cycle 1. Cycle 2 is going to end at 2 pi. Then you break each cycle up into halves. That's going to be pi halves right there. Here's one suggestion. If the fractions are still really bothering you, actually everybody do this for a second. Get out your unit circle. Come on. It can be helpful in this. Look at 0 and then look at pi on your unit circle. What's halfway between that? What's halfway between pi or 0 and pi on the unit circle? Pi over 2. So we go to 0 to pi over 2, then to pi. So what's the next logical step on the unit circle? 3 pi over 2. You could use the patterns on the unit circle sometimes to help you. But anyway, then break those up into smaller chunks. And we're ready to graph. This is a cosine, though. Cosine doesn't start right on the midline. It starts at the top of the amplitude. The amplitude is 2. That means it's 2 units above the midline. So where does it start, actually?
X-axis.
Starts right down here at 0. That's 2 units above the midline. That's the amplitude. So it starts up here, 2 units above, then it goes to the midline, then it goes 2 units below, then back to the midline, then it stops its cycle 2 units above. Then it repeats. Back down to the midline. Ooh, that one was pretty good. Okay, guys, stand up for a second. Everybody needs to stand up. Stand up! We need one little break here before the dash to the finish line. There's one more thing we have to do. What is it? Yeah. Okay, go back to the beginning of your notes, y'all, where I had you draw these little teeny graphs. If you still have room, I want to add one more. Because I know you know this already. This is not the first time you've had this kind of transformation. If I ask you to graph this, in parentheses, x minus 2 to the second power. What does that mean? Goes to the right. 2 units. And the parabola would look something like that. So how do we know whether we're going to be moving up, down, or left, right? If we look at these two side by side, how come this one moved down, but this one moved to the right? The parentheses in this case, yeah, you might be able to use the parentheses. But what if it were a function that didn't have parentheses, like y equals the square root of x plus 2 here, and then the square root of x plus 2. Both of those do different things.
Yeah.
Now, and they don't have parentheses either. So how do we know which one's which? Is this? Would you call this inside of a function or outside? That's a vertical shift. Is this inside or outside? That's a horizontal shift. What about this minus 2? Is this inside or outside a function? Inside. What about this one? Outside. Okay. Anything that's inside of a function moves it left or right. Anything that's outside moves it up or down. That's the discussion you should have had 2 or 3 times with different functions throughout the last couple of years. Because take a look at number 9. Turn your worksheet over to number 9. What the?
This is what we do.
There's a few more things different about that, yeah? Is there a number inside the function? Okay. And then there's a number outside. So we're not only moving left, right, we're also moving up and down. So here's what you need to write. Hurry, copy that down. The thing you need to remember, if it is inside of the function, it moves opposite of what you would think. If it's theta minus a number, it moves to the right. If it's theta plus a number, it moves to the left.
Is it the same with outside?
Nope. Outside, if it's plus a number, it moves up. If it's minus a number, it moves down. So let's take a look here. Y equals 2 times the sine of theta minus pi halves plus 1. So it's same story. We still need the amplitude and the period. And you find them the same exact way. Amplitude's 2. Period is 2 pi over b. Remember, it's 2 pi over b. And b is still the number in front of theta. What is the number?
1.
So it's 2 pi divided by 1, which is 2 pi. You guys okay so far? Same formula, 2 pi over b, and b is still the number in front of theta. It's just 1. Okay. This, you got to pay full attention to this, because this gets a little more complicated than anything else we've done today. So draw your graph. Now let's decide, are we moving up or down?
Yeah.
We're moving up 1 unit, and then are we moving left or right?
Right.
Moving to the right. Okay.
Draw the y-axis more symmetry.
Yeah, we're going to redraw the y-axis too. So first thing is we're going to draw where the midline is. Where's the midline? Up 1 unit, isn't it? So draw your midline. Okay. Now on the midline, let's say we're going to call this 2 pi. Wouldn't this be pi right here? Yes, no? What would half of that be? How far to the right were we supposed to move? We were supposed to move pi halves units to the right. So I'm also going to move the y-axis. Why did I move it right there? How far over did I move it? Pi halves. Why did I move it pi halves to the right? Isn't that what we were supposed to do? Pi halves to the right?
It's negative, so you have to.
So I need you guys to understand what's happened here. I went pi halves to the right and up 1. Isn't that exactly what the transformations were? So instead of calling this 0, 0 origin, let's just consider this to be our new origin, like this is 0, 0. Okay? You still with me? What if this had said plus pi halves instead of minus pi halves? I would have shifted the y-axis to the left, so I would have had a dotted line over here. You guys following? So when you have vertical and horizontal, I would shift both the x-axis, that's the midline, and I would shift the y-axis. You clear?
Yes.
Okay, now, I'm going to try to go a little bit slower on this. What is the period? It's 2 pi, right? Now, I marked this as 2 pi because that's 2 pi units away from the original x-axis, or the original y-axis. We need to start here and go at a distance of 2 pi. Are you following? We need to go a distance of 2 pi from this new point we created. So, just so I don't get confused, I'm just going to pretend those aren't there. Okay, this is some fraction stuff. If I'm starting at pi halves, you guys listening real careful? if I'm starting at pi halves and I have to go out 2 pi units, where am I now? If I start at pi halves and I go over 2 pi units, so I start at pi halves and I go over 2 pi units. You understand the math problem here? Why did I say I'm starting at pi halves? Because that's where I'm starting, at pi halves. Why do I say add 2 pi? That's the period. So where am I? Isn't 2 pi the same as 4 pi over 2? So if I have 1 pi over 2 plus 4 pi over 2, then I am at... So I'm going to come out here and mark that as 5 pi over 2. This is the end of one cycle, yes? Because what is one period? What's the length of one period for this function, you guys? Come on. But we didn't start at 0, we started at pi halves. So I had to start at pi halves and add 2 pi. You clear? Now here's where I'm going to take it a little easy on you. You have to mark and label the first cycle ending. But for the next cycle, just go out there and put a little tick mark. I don't care if you label or not. Just go out there and put a tick mark. You guys okay with that? Alright, and then you have to break up each of these. So put the halfway point, and then break that up. And then here put the halfway point, and break that up. All I really care about on these ones, you guys, is you're starting in the right place. Are we starting in the right place? That's my biggest concern. Did we go over to the right pi halves and up 1? Okay. And did we go over pi units? Or 2 pi units, rather? That's really all I'm concerned about on these. So, we're doing sine or cosine. What does that mean? Starts right at the midline, right? The sine function starts right at the midline, doesn't it? Yeah, the sine function starts right at the midline. Now, what's my amplitude? So from my midline, I'm going to go up 2 units and down 2 units. So starting here at the next tick mark, I go up 2 units, then back down to the midline, then down 2 units, and the cycle ends at the midline. Yep. And then the cycle starts again. Up 2 units, back down to the midline, down 2 units, and it stops at the midline. That one's a little complicated, isn't it? It's going to take a little more practice. That's why you have a few more to do with homework. All right? That's about all we have time for.